Hello, Ms. Wicker. This is for the Operon project where I will discuss slash present to you the structure of the operon and processes of both inducible and repressible operons. First, I'll talk about the structure or each part of the operon. First, let's start with the regulatory gene. The regulatory gene essentially transcribes itself to make itself into a mRNA. Then the mRNA will go to a ribosome and make itself into a repressor protein. The repressor protein is essentially an on and off switch for the entire operon system, but as you can see at the moment, it's inactive. Next, let's move on to the promoter. The promoter is the place where the RNA polymerase attaches itself. And from there, as you can see, the RNA polymerase, if the operator is not blocked off, will decode slash transcribe the entire polypeptide chain up there. But let's move on from that. I'll explain that later. This is the operator, which is where the place, if the repressor protein has the same shape, will go attach and it will turn off the entire system from occurring. And this is the code for the polypeptides. And essentially, it's the code that's going to be transcribed for whatever protein you're going to make. This is the mRNA chain that's made from the RNA polymerase decoding slash transcribing all this code. And we have the ribosomes attached to it, which will make whatever polypeptide that you're trying to make. Now, let's move on to repressible versus inducible. First, I'm going to start with repressible. And essentially, the repressible protein, or operon, is usually in a on state, which means there's no inhibitor, which is the repressor protein, stopping the entire process from occurring. Now, as you can see, this is in its on state. Every single process is occurring, where the RNA will slide down, transcribe everything. And by the way, just a thing, this is called polycistronic mRNA because a lot of polypeptides are being transcribed by this one RNA polymerase. Let's move on. And essentially, it will make all these code. The ribosomes will translate it into whatever polypeptide you need. Now, let's introduce something new. How will we turn this off? Well, that'll be with the co-repressor. Oh, oops. Whatever. Forget that. The co-repressor will turn this into an active repressor protein. Now, it will fly all the way up here and attach itself here. And as you can see, it's blocked off now. This RNA can't go through. So the entire process will not occur. And there's practically one big reason this will happen. It's because the whatever polypeptide that needs to be formed is not needed at the moment. That's practically it. All right, let's rewrite everything or remake everything like it was originally. And now, let's talk about an inducible. An inducible, let me move this, is usually in an off state. Essentially meaning nothing will occur unless something called a inducer is introduced to this system. Everything else is the same. The structure is the same. As you can see, the regulatory gene makes itself into an mRNA by transcribing itself. The promoter still has the RNA polymerase. The operator still attaches to the repressor protein, which is inactive at the moment. And we have a code. We have the code for the polypeptide chains. We have the ribosomes attached to the mRNA chain, and which will not make any polypeptides, as the RNA polymerase cannot transcribe these code of polypeptides. Now, so as you can see, unlike the repressible version, this is inherently turned off. How would you turn this on? Let's remake everything once again. It's if you induce something, or I just hinted at it, the inducer. The inducer will now attach itself to this, and now the shape is completely different. As you can see, it can't attach. Oh, come on. And now, since it can't attach, the process goes as it is. It is what it is, and it just goes on. It slides down, makes whatever protein or polypeptide transcribes it. It goes to the ribosomes, to the mRNA, and makes whatever polypeptide you need. And that's essentially it. This is the difference between inducible and repressible operon systems and the entire structure of the operon system. For both, they're the same. All right, see ya. But come on, where's the power button?